Hello, coders. Today we'll be solving Geeks for Geeks problem of the day, bottom view of binary tree. You are given the root of a binary tree and your task is to return its bottom view. The bottom view of a binary tree is the set of nodes visible when the tree is viewed from the bottom. So basically you have to find the bottom view of the tree. We have the tree and basically we just have to look from the bottom, and whatever the nodes will be visible, that we have to return, right? So if I take this particular tree, then if I viewing from the bottom, then 5, 10, and then there will be 4 and 28 and 25. These will be the nodes will be visible, but you can say that 5, 10 and 14 will also be visible from the bottom. So it's correct that 14 is also visible, right? But if you see that yeah, the problem statement is stated that if there are multiple bottommost nodes for a horizontal distance from the root, then the later one in that labeled auto traversal is considered. Means if more than one means this particular 14 and 28 both will be visible from the bottom. But I just have to take the latter one, that is the last one at the same horizontal distance from the root. Means if the root is at zero level of the x-axis, then 28 and 14 both will be at plus one distance from the root, right? But and since the problem statement says that we just need to take the last one from if we getting more than one node at the same horizontal distance at the same last level of the tree, right? Okay, so 28 would be in the answer. And if we take 4, so 4 will be the last node at the zeroth level from the root, then 25 and 28. So these are the nodes we have to return in the array, right? Okay, how we can solve this problem? As you can see, we have to uh, if I'm standing at any node, then I should be knowing what is the horizontal distance from the root, right? Like if I'm standing at this particular node with value 8, then I should be knowing that its horizontal distance is minus 1 from the root, right? And if I'm standing at 22, then its horizontal distance would be 1. So how we can know the horizontal distance? It's very simple. If I'm standing at 0 and moving towards the left direction, the left node, then I will minus 1 into the x distance of the parent, right? So it will be the parent node of this particular left child. So its distance from the root would be parent's x distance minus 1, right? Like it's minus 2 because its parent x distance is minus 1. And similarly, for the right node also, if the parent is having x distance, then right would be having x plus 1 distance. Okay, so now we know that the horizontal distance of a node from the root, right? Can I solve the problem by knowing just the x distance? Let's try out by just knowing the x distance. So we will be using in order traversal, and since the minus 1 and minus 2, these are also the distances. So better I will make a map to store the nodes. The last node I will be counted at a particular horizontal level, right? So it will be int comma int map. Let's write the lambda function. So I will be returning nothing, and I have to take the node and also the horizontal distance, right? Okay, so just the syntax of lambda function. Okay, it's fine. So if I get a node, then I will be moving to the left once and in the right once. So if and the parameters will be node star. Let's make it node and x distance, right? So going in the left direction. So yeah, and the x distance now would be x minus 1. And we will be keep storing the last node at a particular level. So I will store at x level the value of that node. So it's a basically data, and I will move in the right direction, and the horizontal distance would be x plus 1 this time, right? Okay. So basically, I can say that after this traversal, we would be having all the nodes at each horizontal level. So just make a list. That is a vector for the answer. I will iterate over the map, and the map has two values. Basically, the key would be the horizontal distance, so it would be x and the value of the node. So I will be storing the value. So okay, now I will return the answer. So let's run this particular code. it's empty. It is not having any value. Let me check out this. Why so it is so. So basically, I started with the map and okay, because I haven't called the lambda function. Okay, so calling with the root value and yeah, so with the root node and with the horizontal distance of the root will be 0. Okay, now again calling. Now this time you can see the compile after the compilation, the output is 4, comma 2, comma 1, comma 3, comma 6 means one value that is the expected output has a value 5, but our answer has value 1. Let's see what basically the error is. So basically what I'm doing, I'm going in the left, I get the 4, right? And I will be getting just one value for this -2 level, right? So map has a correct value that is 4. Then I will move back to the 2 and I will store at -1 level the value of 2. Okay, I will come back to the 5 and I will store the value 5 at 0 level. It's fine up to this point. But as get back to the 1, it's also have the level 0, right? And since it has the value 0, so it again updated the map with the value 1. And since this is the reason our output has the value 1 in place of 5. Okay. So how we can remove this particular bug? So to remove this bug, I have to maintain the vertical distance also. Because 1 and 5 are at two different vertical distances. And since we have to find the bottom view of the tree, so I just have to consider the bottommost node of the of that particular vertical level, right? Okay. So we have the intuition that now we have to also be aware of the vertical distance of a node, right? So yeah, so we can store the vertical distance in the map itself. For every horizontal distance, we will have two different things now. One would be the value of the node, and second would be the vertical distance of that node, right? In this way, I can easily maintain that whenever I get a node with the same horizontal distance, but I can check either that particular node is at the vertical distance which is smaller or greater or equal to the previous vertical distance or basically previous node, right? So this y distance would help us to maintain the same level condition of the problem. Okay, so okay, now we have map with which will be mapping the x with two values. One will be the data of the node, and second will be the y vertical level of the node, right? Okay, so for that I have to also take the y, and yeah, I have to update the parameters in the member function. Now in the function call also, now every time I will go to the child node, the child node would be the +1 level from the parent node, right? Always the +1. Either I'm going in the left or right. So vertical level would be the y +1. Now I will check in the map if map x dot second, the y, basically the vertical order of the node is um, now smaller than or equal to the y, right? That is the current level of the vertical level. So if the previous node is at the same level or the level which was the smaller level than the current vertical level, then I need to update the map with the updated key, basically updated values. That would be the node data and also the y distance. Yeah. So I have updated the map with two values that one will be the vertical level and one will be the value of the node. Okay. Now in the function calling also, the root level will be the 0 level. And as I will be going into the child node, I would make +1 to the child node's vertical distance, right? Okay. So now this time our map, uh, the value of the nodes would be it dot second because I want not second, it would be the first because I want the value of the nodes, right? I hope this should return the correct values. Let's comment out this particular. Okay. Now again, running the code. Okay. So now I am getting the horizontal distances, right? So of course I'm okay. I guess I'm not maintaining the map with the correct values. Okay. It should be it dot first, not first, but second dot second, right? Because every key has a value which is pair of integers, and we want the second integer, not the second, but the first. Sorry, I will again get the wrong values. Okay. Now it should have the correct values. Yeah. So now problem is successfully be structured, and basically its intuition is very clear to us and approach is also clear. Let's submit the problem solution. Yeah, it's fast. So yeah, this is the solution of this problem. we manage the vertical distance condition, which was written in the note, that if I get the multiple bottommost nodes for horizontal distance from the root, then the latter one in the level order traversal is considered. And for the horizontal distance, we manage this particular condition with the variable x, that will be the x distance from the root. Hope this is clear to you. Thanks for watching.